Hi there. How's everybody? I wanted to take this short. Wanted to make this small lecture on the concepts of a stack, right? Spelled stack. And since we're doing this in Python, right? Normally, Python doesn't provide a stack data type, right, or data structure rather. Not like Java. If you're using Java, you do have a data type stack that you can write and create, right? However, Python provides other data types such as list that you can use to pretend, not pretend, but mimic the functionality of a stack. So how does a stack work? Stack, you have basically, it's like a bucket or a box with you can imagine books in it, right? Just various books, and just imagine that these books kind of fit the size. All right. One thing is that in this box, if you want to put anything in, you have to put on the top. All right, that's going to come here. And if you want to take anything out, it have to go from the top. You cannot just pull anything from the middle. And it's just like a very the precise size box where all the books are just sitting in. So that's the whole idea of a stack. All right. And if I had to do create another stack with numbers, so let's just say the first number coming in, I'm going to put an order here. First number coming in is 72, right? So 72 will go right at the bottom. Second number coming in, number 2, is 35. So 35 would come right here on top of it. And then number 3, 45 is I'm pushing 45 in. So when you put stuff in, you push stuff in, right? Push. I'm pushing 45 into my stack, right? Oh, wrong place. This should go here. That is need to come out, right? That needs to go here. 45, right? So like that. Now let's just say for number 4, I'm going to put 80 in here. So 80 comes right in. I'm pushing in. The main term you're going to use is push. I'm putting 80 in, right? 80 in, and then right, this one is, so these are all push, right? I'm going to put arrow down here. These are all push, right? And then step number 5, I want to pop, right? Pop means I want to take something out. Now, since the stack is designed this way, you cannot just take out 45, 35, or 72. You have to take out the top element. You have to take out 80, right? So 80 is pop, right? That means 80 will no longer be here, all right? And if I want to do another pop, right? If I want to do another pop, as step number 6, right? That will take away. Now instead of 80, my 45 would go away, right? 45 is out. 45. You see that? So this is pop right here. So stack has, so far we have seen 2 methods. If you want to add anything to the stack, you do a push, and if you want to take anything out, you do a pop. Not anything out. If you want to take the very last element that went in the stack out, would be a pop. So the cool term the stack uses is last in, first out. All right, last in, first out. That means whatever element went in the last is the first one that can be popped out, right? I cannot take out 72 or 35. I had to take out whatever was here, which was 80. Last in, first out. So these 2 are the methods of a stack. All right, other methods on a stack also that we can use is, one of the one is called empty, or is empty, depends on what language you use, but basically, right, stack tells you, if the right, empty is another one you can use. Most stacks provide empty function, which tells me whether is a stack anything in it, right? Other functions you can also use on a stack is top, right? Top tells me what is sitting right here on top, right? What is sitting right on top. And then, so those 2, and sometimes, you can also do like a function called search, or maybe get, depending on, it can, if you do like a search 35, it will tell you where it is, okay? So some various kinds of functions available when you are doing a stack in Python, right? So let's go ahead and let's walk through how we're going to implement. Oh, by the way, like I said before, like I said, that we don't have, we don't have a stack data type in Python, right? We don't have one. So how do we go about implementing one? So you have to use a data type that's available, right? And one of the ones that's available for us to use is called the list. List is pretty cool because list also has several functions that you can use, right? The several functions you can use to create one. All right. Now, also, so that is there, right? We've looked at stack. We've looked at list. List also. Well, list is like an array, right? List is like an array. But the way this list could be used, right? The way this list could be used is you could, list has a couple of methods that you can use. So I'm going to draw my list like that, right? And you all have seen the other video that I did on list. So list is like an array, all right? And every time if I want to add item to it, item's going to come right here. So I'm going to do append. In Python, append means to put it here, right? Append here. And then also there is a pop, right? There's a pop. Pop will remove that item, right? That big arrow this way, pop will remove it. So list you can use, if I turn this list vertically, right? When I append, I mean, it depends on how you see it. You can put items in here. When I do a pop, right? Pop means remove items from the top. But list has other functions too that you can use, such as insert, remove, clear. Many items that many functions out there that you can use to get the same stack functionality, right? So with that, let's go ahead and open our IDLE and see what we can do with stack. So IDLE, right? As soon as this comes up, I'm going to quickly. What happened to this other window? There we go. Taking a while for this to build up, right? So stack, I'm going to move it to the side. And then, all right, first things first, new file. And I'm going to save this. Save as desktop Python code, right? So this would be my stack. Stack. Okay, no confusion here. If you, like I said, when you want to implement a stack methodology in Python, right, we have to use a list, and let's just keep it very simple. So I'm going to call it stack. Stack is equals to, that is an empty list, by the way, right? The empty list. All right, and then if I want to add items to it, right, I'm going to say stack.append. Now let me do this. I'm going to simply do a print stack, right? That basically will give me what's in there, and then append. I'm going to append. Let's just put, what numbers did we have? Let's put 80, right? 80, and then stack.append. I'm going to put 35. All right, I want to print this out and see what is currently in the stack, and then I'm going to add some more. Stack.append, and that would be 77, right? And then stack.append 34, right? Now print this out again, print. So this, the code that I've written, I'm trying to mimic. This is the push, not a there we go, push methods of a stack, right? This is the push method of the stack. So basically, when you push item onto a stack, right, they all get pushed to the top. And depending on how you see this stack, this basically should get appended to the end. So I'm going to run this, and you should see, right, numbers are, right, the first item I push is 80, second is 35, then I push 77, then I push 34, right? I mean, it kind of makes sense. Now, this is the top of this bucket that I mentioned, right? And this is the, the box I mentioned, right? This is the top, the first item, second item, third item, fourth item. Right? That is how you kind of visualize it, even though it's horizontal. All right, that is that. And then we're looking at the pop methods. Not, is it pop? yeah, pop methods of a stack, right? And that one is very simple because the stack already has a stack.pop. It already has a pop method that you can clearly write. So print again stack, right? So this stack, this should have removed the last item inserted, right? The very last item that we inserted. All right, and then print stack, and then I'm going to say stack.pop, right? So this should now take out what's the last item sitting on it. So let's just see if that is even happening the way we want it to work. All right, so running this code, you see, very well. So now this was our first part of it, and then we did a pop. So it took away 34, and this is what I'm left with. And then we did a pop again. So it took away 77, which is the top of the stack. Now I have left with this. So even in Python, you can implement stack, some of the stack method. Actually, you can stack all of the methodology in stack by by writing, using append and pop. All right. Now also, how do we go about finding out? So the list, as far as I know, list does not give you a function that tells you whether it's empty or not, right? You can do other things. You can basically do a get the length, right? Get how many items in there. You can do one of those and compare if it's equal to 0, right? And right, you can get one of those. And so maybe we can try this. And you can simply create a function for that, right? I mean, that will work too. So maybe I should do that too. Maybe I can say define, right, is empty, empty. Hopefully that's correct. Doesn't take anything. Actually, let's just say it takes the stack, right? Takes the stack. And here I can check, basically I can simply check if the if length, I believe that's how it is, length stack is equals to, if the length equals to 0, then return, right, true, and then else, true, and then I'm going to do an else, right? Simple kind of stuff, right? Nothing major here. So then I'm going to do a print is empty stack, right? Now that will give me an error because I need to take this thing above. I need to take, anytime you write a function in Python, it needs to be, you want to have it somewhere on the top. I mean, just to make it simply to run this properly, right? So it says it's a false. All right. So now, and you can see you can do one of those, is empty. The other function that's important is sometimes in stack is the top, which simply means what is on the top. What is on the top? So in order to do that, right, what you got to do is you have to write another function, which would be def top, right? Also takes a stack right here, right? So how do we find out what's on the top? And the way you're going to do that is first thing I'm going to check. You can check if length of stack is greater than equal to 0, right? That means there is some items in here. Then I can do return, right? Stack square bracket, and I can put in here what item is on the top of the list. I mean the very last item, right? So that'll be length of stack again, and I believe -1 because of the subscript, right? And if not, no, and then I can put else, I don't know, return minus, well, if it's on the top, right? Return null is a null, no, null is none is an, I thought none was in Python code, return none, right? Top. So now I can put down here print stack and then print top. Let's see if my top function works. Give me a 35, right? So if I, right, if I, now, you know, I mean, these can be improved a little bit more, right? You can polish it up, you know, a little bit more just to make sure that there's no errors, but you can see, I'm just showing you in a very simple way how you can implement some of these methods, right? We got empty, we got top, we got append, I mean, the push, right? This is basically a push, this is pop right here. And then what else are we missing? What else are we missing? All right, so the other one that you can use, let me see. Okay, so we can also do this. That will work for us. Is, let's just say we want to have a function called search, right? Because when I've written this in Java stack has a function called search. So I'm going to put a search here, search stack. All right, and this one basically it will say stack. Oh, not search. I need to put another str, right? What am I searching for, right? Search text. I'm looking for search text. So I'm going to say return stack dot index, right, of text. So that means basically, hey, tell me where the stack is. I mean, where wherever the element I'm looking for in my stack. So going down here, I'm going to call that method. I'm going to say print stack. Oh, not stack, search. Is it search? Search takes a stack, and I'm looking for 80 because I know 80 is there. So running this should give me a good old value. All right, gives me a 0, 80. So I should be able to put 35 here as well. All right, because 35 is also in my stack. Running that should give me a 1 because it's at position 1, right? I mean, well, it's at position 2, index is 1. So that is the basic implementation of a stack. I mean, you can use a you know, something like a list to get that to work. All right, so hopefully this helps. I'm going to turn this off, and then I'm going to create another one on a queue.